Hello everyone, welcome and thank you for attending today's IBM Middleware User Community Ask the Experts webcast. My name is Kelsey Lammers and I'll be hosting today's webcast. Our topic for today is Configuring Object Server SSL on Netcool OMNIbus 8.1. All phone lines are currently in listen-only mode. There will be a question and answer session towards the end of the presentation. However, you may ask a question at any time during the presentation using the questions window located in the control panel. Also look for a forum link in your chat box and feel free to continue any discussions after the webcast in this forum. Tomorrow we will have the recording and slides of today's presentation available on the IBM Middleware User Community website for you to access. You will receive a follow-up email with a link to the archives. Now I'd like to introduce our speaker for today. We have joining us Christina Grimes. She's a senior software engineer with IBM. Thank you, Christina, for joining us today. The floor is now yours.
Thank you, Kelsey. Hello, I'm Christina Grimes. I'm a senior engineer with IBM, and I specialize in Netcool OMNIbus core and also integrations. Today I'll be talking about configuring Object Server SSL on Netcool OMNIbus 8.1. The steps here are for 8.1 or 7.4 FixPack 2 and later. The steps will be same in both of those versions. If you have any questions, please put them in the chat and we will answer them as we go through this presentation. We like it to be as interactive as possible. And that since it's a difficult configuration topic, if you can just put your questions in as soon as you see the information on the slides, it will help to answer the questions as we go through it. For the agenda today, first I'll talk about configuring Object Server SSL on the primary and backup object servers. This will be an example configuration for creating the certificate authority and the primary and backup certificates for an AGGP and AGGB object server and distributing those certificates to clients. I'll also go through an example configuration for an Object Server Gateway SSL configuration, looking at the AGG gate configuration in particular. And we'll go through an example probe SSL configuration for an NT-TRAPD probe. Also talk about connecting event lists, NCO-SQL and NCO-ping with SSL. And then at the end, we'll touch on FIPS 140-2 and SP 800-131 enhanced encryption, and some of the differences that you'll have to do if you're planning on doing those enhanced encryption algorithms. The first step to enable SSL on the object server is to configure the omni.dat. So you need to specify an SSL port in the omni.dat file. During setup, it's usually good to have both an SSL port and a non-SSL port so that your clients that you have currently connected can continue to connect non-SSL until you complete the SSL configuration. Because you have to configure SSL both in the object server and in every single client that connects to the object server, for a period of time you usually have to run both SSL and non-SSL ports. Then once you have all of the clients configured for SSL, then you can switch that omni.dat file and remove the non-SSL port, so the object server will only be listening on the SSL port and it will only allow SSL connections. So once you've configured the omni.dat file with an SSL port, you do have to restart the object server for it to start listening on that port as well. The next step is to create the key database. The key database would have to be created on each object server, every probe, and every gateway. Anywhere that you have OMNIbus core installed and have clients that are connecting to that object server, they would also have to have a key database and the certificate authority within it. This is the command to create the key database. In OMNIbus 7.4 and 8.1, we use the ncgskcmd command. It's a keydb-create-db. The key database location on Unix, it has to be nchome etc security keys omni.kdb. You can't use any other location or any other key store. On Windows, the location has to be nchome ini security keys omni.kdb. When you're creating the key database, you have to use the --dash option, and this stores the encrypted password within that same directory. You don't specify the key store password within the object server in any properties, so it needs that stash file so it can access it. When you create the key database, you also use an expire option, and that's the number of days before the key store password expires. Unless you have a security requirement, the maximum value for that is 20 years. So in the examples within this presentation, I use the 20-year configuration as the maximum value. You might have a security requirement to have that at a lower value and to reset that password at a certain interval. The minimum value is 366 days. Also, if you're planning on enabling FIPS 140-2, there are several password rules that have to be configured within your key store password. So the example password that I have here meets all of these password rules. Even if you're not planning on using FIPS 140-2 mode, I would say it doesn't hurt to go ahead and use these password rules in case you ever need to configure FIPS mode in the future. Then at least your password is already set to these rules and you won't have to recreate the password at a later and recreate the key store at a later date. The FIPS mode password rules, where the minimum password length is 14 characters. It has to have one lowercase and one uppercase character and one digit or special character. Each character must not occur more than 3 times in a password. No more than 2 consecutive characters can be identical. And all the characters must be in the standard ASCII printable character set. Do we have a question?
It looks like we do. Does this apply to Linux and Windows Netcool?
Does this apply to Linux and Windows? What was that last word?
Netcool.
Netcool. It does. This would be both for Linux or any flavor of Unix and Windows as well. The examples that I have, each of the examples, the database that I use is all done on Linux. So you'll see that the database that I reference is the NC Home Etsy Security Keys omni.kdb. You can use the same exact commands on Windows, but the key database location is different. It would be the NC Home INI Security Keys omni.kdb. Okay. Once you have the key database created, the next step is to create the SelfSigned CA certificate. Just a note here, you don't have to use a SelfSigned CA certificate. If you want to use an external third-party CA, you can do that. I'll go through the steps to create a self-signed certificate authority just for OMNIbus in case you want to go that route. But I'll try to point out that if you're using a third-party CA certificate, you wouldn't need to do this step. This is only if you want to do a self-signed certificate authority. Where should you put the certificate authority and where do you want it to be located? You can either put it on its own standalone server or you can put it on one of the servers that you already have. In my case, I put it on my primary object server because that is the primary system within my OMNIbus environment. I put my certificate authority on my primary object server, AGGP. But you can put it on any server, any certificate steps that you need to do with a certificate authority. You need to copy the certificates over to that certificate authority for it to sign the certificates and then return them. This is the command to create the certificate authority. Just to point out some of the command steps, you again have it create the certificate with the key store database, which has to still be that standard location, NC Home Etsy Security Keys omni.kdb on Unix, or NC Home INI Security Keys omni.kdb on Windows. The label here can be any label that you would like it to be. It should be something that you can identify it as a certificate authority. In my case, I used ncoms_CA. That could be any name that you want it to be, so that I know that that label is my certificate authority. What I also did is I have it match my distinguished name. So you can see that my label here is NCOM CA, and my distinguished name, common name, is also NCOM. So I can just easily identify it. The label is really something for you to help identify it in the key store. The password here is my key store password, so the password that I created when I created the key store in the last step. The distinguished name, NCOM CA, and here I put a long string for my distinguished name. The common name here matches my label name. Again, the expiration can be in the range 366 days to 7,300 days or 20 years. In all my examples, I use the 20 years to have it the maximum time. When you're creating the certificate authority, you always have to pass it the option -CA true, and that identifies it as a certificate authority. The last part of this command in here is only needed if you're planning on doing FIPS 140-2 and SP800-131 encryption. And I'll touch on that more at the end of this presentation. If you need to have TLS 1.2 for your SSL encryption, then you need to use these options and also enable FIPS 140-2 and SP800-131 encryption. So within this command, you would have to add the -size, which specifies the key size length. For SP800-131, it has to be 2048, which is the maximum value. And also the signature algorithm has to be SHA 512 with RSA. Once you have the certificate authority created, you can go ahead and distribute that certificate authority out to all the clients. On each of the clients that you'll have connecting to the object server, whether it's an object server gateway or a probe, an event list, an administrator, on each of those you also need to create the key store and import the certificate authority into that key store. If you're planning on using a third-party certificate authority, usually third parties will use both a root certificate authority and an intermediate issuing certificate authority. So you would need both of those to be imported into any of the client key stores. This is the command to extract the certificate authority. If you have a standalone certificate authority, this extracts my NCOM CA certificate authority that I created. And this creates a file, ncomcacert.arm. And that file is a file that I would then have to copy to each of my clients and then add it into my key store on each of the clients.
Christina, we have a question.
Okay, Wade, go ahead.
Where can I download this presentation? I believe it's going to be made available after your presentation is complete. But
yes, it will be made available after the presentation is complete. Tomorrow, both this webcast and the slides will be available on the middleware user community. And Kelsey, I believe, will send out a link to both of those afterwards. So now that I have the certificate authority created, I've even exported it so I have a copy of it that I can distribute out to my clients. Now I want to create the server certificate request for my primary and backup object servers. So on each of my object servers, AGGP and AGGB, I'm going to create a request for a digital certificate from the server. You would already need to have the key store created on AGGP and AGGB before issuing this command. So the only difference between these commands is the label. So they are two different certificate requests, but I use the same common name on both of them. So I wanted to point out that on AGGP, my label is AGGP matching my object server name. Your label should always exactly match the name of your object server itself. My distinguished name, however, is the name of my virtual object server, AGGB. And it's the same thing on AGGB. When I create the certificate request on it, my label is AGGB. My distinguished name is going to be my virtual object server name, AGGV. And this will result in two separate certificate request files. I'll have a primary request.arm and a backup request.arm file.
Christina, we have another question.
Okay, go ahead, Wade.
What is the impact of setting up SSL within the object server on your OMNIbus web GUI?
So web GUI would also have to be configured for SSL as well. This presentation is just focusing up on the object server configuration for SSL. So in the beginning I talked about how in the omni.dat, usually for a period of time to run both an SSL port and a non-SSL port. And then once you get all of your clients, including web GUI, configured to use SSL only, then you can go and switch that off and configure the omni.dat only to have an SSL port, so the object server will only be listening through SSL. As a follow-up to this, in 2 weeks we're planning another presentation on the impact SSL configuration. And 2 weeks after that, we're going to be looking at doing a web GUI SSL configuration. And there are additional steps that you'll need to do in web GUI as well to configure web GUI to connect to your object server. Let us know if you have any additional questions about that. I'll walk through the example commands here. So this is a certificate request, again pointing to my key database. The label matches the exact name of my object server. The password is my key store password. The distinguished name, common name, matches the name of my virtual object server. With this command, again, if you're planning on doing the FIPS 142 with the SP 800-131 enhanced encryption, you'll need two additional options on both of these commands, the -size 2048 and the -sig-alg or signature algorithm SHA 512 with RSA. And then the -file is my certificate request file that's going to be created from this command. So once I have that certificate request file, I need to copy both of those files back to my certificate authority. In my case, I put my certificate authority on my primary object server. And then my certificate authority needs to sign those requests. So for using the self-signed certificate authority, you can copy your primary and backup object server request files to your certificate authority. I put it on my AGGP object server. If you're using a third-party CA, you would usually send your server certificate request out to that third-party CA to be signed, and then they would issue you your server certificates. On my certificate authority, for my self-signed certificate, these are the commands that I would issue. The database is, again, my key store database where I have my certificate authority, my key store password. My label here is the label of my certificate authority, NCOM-CA. The target is going to be the server certificate that gets issued, my primary cert.arm. My expiration time here is, again, 20 years. The signature algorithm, again, if you're planning on doing SP 800-131, you have to have this option here. If you're not planning on doing it, it's optional. And the input file here is the certificate request from the last step, my primary request.arm and my backup request.arm. Both of these are the exact same command. The only difference is the input file, primary request.arm, backup request.arm, and the target file. I have two target files, my primary certificate for my primary server certificate and my backup certificate for my backup server certificate. So this outputs and gives me two files, my primary certificate and my backup certificate, which I then need to copy to each of my object servers. So now that I have my signed server certificates, I will copy my primary cert.arm file to my AGGP object server and my backup cert.arm file to my AGGB object server. The server certificates you do not need to copy to any other clients within the environment. You don't need these server certificates to be on any client systems, probes, or gateways. They only need to be on the object servers. This is the command that you would use to receive those certificates into your AGGP and AGGB object servers. It's the same command except for again, the primary cert.arm goes onto your AGGP object server and your backup cert.arm goes on AGGB. At this point, you can list your key store contents also, and here's some example commands so you can see what's within your key store. At this point, you usually want to see your certificate authority on your primary and backup object servers, and your primary server would have your AGGP server certificate, and your backup object server would have the AGGB server certificate. Now let's talk about distributing the certificates and what exactly needs to be on each of the clients. Within each of the key stores, on your certificate authority, it needs to at least have your NCOM CA, or your certificate authority and private key. In my case, I put my certificate authority and my primary object server on the same system, so it had both NCOM CA and AGGP certificates within it. Each of your object servers needs your CA certificate and your server certificate and private key. So my AGGP key store has NCOM CA and AGGP, and my AGGB object server has NCOM CA and AGGB. All the other clients that I have connecting, probes, gateways, event lists, administrators, they all have my CA certificate, NCOM CA. And just for each of the client systems, these are the example commands that you would use on your probes, gateways, and event lists to export your CA certificate, to create the key database, and to add your NCOM CA into that key database. Again, if you're not using a self-signed certificate, if you haven't set up your own CA and you're using a third party, you would need to add both the root CA certificate and the issuing or intermediate CA certificate into the key store. Now let's go through an example object server gateway SSL configuration. So the key store on the gateway server would contain my CA certificate, NCOM CA, and you would configure your gateway omni.dat file or the server editor with only the SSL entries for your AGGP, AGGB, and AGGV object servers. Now, if you're doing the failover gateway and you're sharing a system with your AGGB object server, this would be a little different because you would still need to have your, if you're going through doing non-SSL for AGGB, you would still have to have that entry as well. The gateway configuration will be somewhat different depending on what your object server gateway is doing. If it's a unidirectional C to A gateway, you have to specify a gate.writer common names, and this is for your aggregate virtual object server with the distinguished name value AGGV. And remember, when we created the certificates, we used the distinguished name AGGV. The common names value that you specify within your object server gateway needs to match the common name within the certificate. For the unidirectional A to D gateway, it's reading from the aggregate layer, so the gate.reader.common names would be AGGV. And for the bidirectional failover gateway, the object server A common names and object server B common names would both be AGGV. And let me show you an example failover gateway configuration on the next page. So this is a default AGG gate failover gateway configuration. You would still have gate.object server A server pointing to AGGP and gate.object server B server pointing to AGGB. The difference here is that you're adding in a common names property, and the common names would be my virtual AGGV on both object server A and B, and that matches what I created within the certificate as the common name. Okay, then let's look at a probe configuration. So the key store on the probe server would contain only the CA certificate. In my case, it was NCOM CA. I would configure the probe omni.dat or server editor with only the SSL entries for AGGP, AGGB, and AGGB. And then I also need one additional property within the probe, which is the SSL server common name property. And this has a distinguished name common name value that I created within the certificate AGGB. So this is an example configuration for an MT-TRAP-D probe. You can see my server and server backup haven't changed. It's still my primary and backup object server names, but my SSL server common name has to match the common name that's in my certificates, which is AGGV. I wanted to have an important note about the event list, NCO SQL, and NCO ping. So once you create the certificates and you have the common name set to AGGV, your probes and your gateways can use the configuration that I just showed where you still have a server backup, and a common names property. There is no common name property for event list, NCO SQL, or NCO ping. So once the object servers are configured with SSL, these will only be able to connect using name AGGV. So you will no longer be able to connect with the event list directly to AGGP or AGGB. You'll get a connection error because the certificate name doesn't match your common name. With the object server name you're connecting to for the event list, NCO SQL and NCO ping has to match the common name within your certificate. So for these clients, you would configure the omni.dat or server editor with only the SSL entry for AGGV, and they'll only be able to connect to the object server name AGGV. If you try to connect to AGGP or AGGB, you'll get a generic connection failure error. For most of the OMNIbus users and operators, they will usually connect to the virtual aggregate object server anyway, so this isn't an issue. But it does come up with an issue if you're the object server administrator and you need to do some administrative tasks on the backup object server, and you can no longer connect to it directly with your event list or NCO SQL. So there's two ways that you can do this. You can either install the event list, NCO SQL, or NCO ping remotely on your own system, and then you can modify your local omni.dat or server editor entry for AGGV and only use your backup object server name. So it would only have one entry with your backup object server, and that way by connecting to AGGV, there's only one entry for your backup. You'll connect directly to your backup object server. Another way of doing this is if you have a backup object server system, which is only running your backup object server and your failover gateway OMNIbus components. You're not running any other probes or anything else on that system. On your backup object server, you could configure the omni.dat with only a backup object server entry for your AGGV object server. And that would allow you to run NCO SQL or the event list directly on the backup object server and connect it only to the backup. Finally, I wanted to touch on FIPS 140-2 and the SP 800-131 enhanced encryption and reasons that you might want to look at doing those along with your SSL configuration. So first, what is the FIPS 140-2 configuration? It's an enhanced encryption. It has different encryption algorithms that have to be used on passwords in particular. So all of your encrypted probe, gateway, process, agent, and object server properties, you can no longer use your NCO Gcrypt, NCO PA-crypt, any of those old NCO crypt utilities. Everything has to use the NCO AES crypt with the -C AES FIPS option, or the password would have to be in plain text. So when you're in FIPS mode, all of your password and all your password property encryption within each of the configuration files has to be encrypted with NCO AES Crypt. It also switches your object server database password encryption. So if you store passwords within your object server database, all of those passwords have to be switched over to AES encryption. On an already configured running object server, this means that all your user passwords have to be reset after the password encryption is set to AES. So you have to go through and set password encryption to AES. Then there's some commands that you go through the database to see which passwords are still stored in the old DES encryption, and they all have to be reset after AES is configured. All the key store passwords must meet the password requirements that I have listed on the key store creation page. You would also configure all of your JREs for FIPS 140-2. And then finally, after you've gone through and done all of the configuration, the last step is to create the fips.conf file. And that is basically when you create the fips.conf file, you restart the object server. That tells the object server it's now operating in FIPS mode with the enhanced encryption. With OMNIbus 8.1 and OMNIbus 7.4 FixPack 2, they also added SP800-131 configuration. That is an additional encryption algorithm, and it allows us to have TLS 1.2 only. So if you want your most secure level of SSL, TLS 1.2, you would need to configure both FIPS 140-2 and the SP800-131. The difference with the SP800-131, and I showed this during the example commands, when you're creating certificates, they all have to be created with the size of 2048 and the signature algorithm SHA 512 with RSA. All the certificates have to be signed with that same algorithm. And within the fips.conf file, to enable TLS 1.2 on each server and each client that's connecting to that object server, you would need to put these properties so that they will use TLS 1.2. That's all that I had to show for the object server configuration. Does anyone have any questions? Please put them in the chat.
Hey, Christina, while we wait for any questions to come in, we had a few questions emailed before the presentation. One of which here would be, what is FIPS-104?
Thanks, Wade. So FIPS 140-2, FIPS stands for Federal Information Processing Standards. So both the FIPS and the SP800-131 are standards that are encryption standards. The FIPS 140-2 is a standard for cryptographic modules. So that means that if you implement all of the configuration for FIPS 140-2, your OMNIbus has been certified against that standard.
Okay, we had a question come in. What is the system overhead for enabling SSL?
There is some additional handshakes that go on when you enable SSL, because everything that connects to the object server, it has to do that handshake and it has to send everything encrypted. I haven't seen anything on the overhead for enabling SSL or any delays that you would see with anything sending information to the object server.
Okay, we have another question. What if we are using an external CA? How would this be different?
So if you're using an external CA, let me go back and go through the configuration steps. If you're using an external CA, some of these steps you wouldn't have to do. So you'll still have to create the key database. You wouldn't create a self-signed certificate. You would skip this step. You would still need to create a server certificate request, but you would not sign this on your CA. You would send this to your third-party CA to sign and return. So you would skip this step to sign the server certificate request. You would send that instead to your third party. And then once your third party CA gave you back the certificate file, then you would receive it into the key stores on both your primary and backup object servers. So the steps are somewhat modified, and if you are using a third-party CA, a lot of them will have both a root CA and an issuing or intermediate CA, and you would need both of those CA certificates to be imported into your key stores, not just on your object server, but on all of your clients.
Okay, we have another question here. Not sure what must be done on a system running probes, but no local OMNIbus database. Go through all the steps as if OMNIbus DB, as if it was an OMNIbus database.
Yes, so if you have a probe server, you would still go through and create your key store. So even if it has no object server database, you would still go through and do these two steps down here to create your key database and import your CA certificate.
It looks like a follow-up on that was when setting up for SSL, will this also include ITM probe and gateway?
Was that ITM probe and gateway?
Yes.
So the ITM probe would be your Tivoli EIS probe, your Tivoli EIS gateway. I assume that's what you're talking about. So yes, this would still be the same steps for your Tivoli EIS probe or gateway. Just like in this example configuration, you'll still need your common names properties. So you'll still set your server and your backup server to the same values, but there are additional common names properties that you would have to configure within the probes and gateways to match the common name in the certificate. The question is for ITNM, for precision. There would be a different configuration for the ITNM probes and gateways because they don't use the same framework usually. I don't believe they have the common names properties. I can check on that and send you the configuration information for ITNM.
Yes, please. Okay, we have another question that came in before the presentation, which is, why would I need both SSL and FIPS 104?
So SSL and FIPS 140-2, FIPS 140-2 is really just a standard for cryptographic modules, so it would be not just your key store passwords, but it also covers all other passwords stored within your object server or within any of your configuration files. If you're looking at SSL, you might want to look at doing FIPS 140-2 and SP 800-131 at the same time if your company has any requirements for TLS 1.2. So we have the standard SSL configuration, but on top of that, if you have a requirement to do TLS 1.2 only, then you would need to do the FIPS 140-2, and on top of that, the SP 800-131 configuration.
And another one that came in earlier is, can OMNIbus directly upgrade from version 7.3.0 to the latest versions, and what will the requirements be for the same?
So to go from OMNIbus 7.3.0 to 8.1, it's a side-by-side migration. As long as the system meets all of the prerequisites for 8.1, you can install 7.3.0 and 8.1 on the same server in two different directory structures and run them side by side while you migrate your 7.3.0 system over to your 8.1 OMNIbus object server. But it's not a direct upgrade in place, so you can't just upgrade 7.3.0 to 8.1 within the same directory structure. It's a side-by-side migration. Some of the steps that you'll typically see when you're going from 7.3.0 to 8.1 is you would run both in parallel for a period of time. So you would stand up OMNIbus 8.1 on the same server in a different directory or on a different server. Then you would stand up your 8.1, configure everything, install all of your probes and gateways on the 8.1 object server. Once everything was up on 8.1, and it was running for a period of time, you might have to do a object server gateway to send the events from the 7.3.0 object server to the 8.1 object server. And then once everything looked like it was running well, then you could do a cutover where you would cut over all of your clients and operators over to the 8.1 system off of 7.3.0.
Okay, we have another one, which is how to use knowledge module database.
And I did not know that the person that asked that question.
I believe that was Faye, and Faye, I believe, is online on the presentation.
Faye, if you're listening, I wasn't sure what that question was about how to use the knowledge module database. Could you give us more information in the question chat? While we're waiting for Faye to respond.
Actually, she responded that question was a request for a future presentation I was asked to ask it, and we'll have to get more information from the source regarding what they'd like.
Okay.
There's also one more that came in before here that I believe you more or less kind of answered. In the presentation, it's a bit long, but here's the question. When using non-SSL, I can NCO ping or connect to either AG-A, AG-B, or AG-B successfully. However, once SSL is configured, I find that the aliasing breaks due to there appearing to be a restriction on either object server only being able to present a single service or CM inside of the SSL certificate. For example, if I create, if the certificate is created with CN is AGGA, then I can connect to AGGA over SSL. But even though AGGB is also listening on the same port for inbound SSL connection, because it is not coded inside the certificate, then SSL communications fail when I try to connect to AG-B. I cannot figure out how to make the object server respond to both AG-A and AG-B, or AG-B and AG-B on the opposite side, with both listening on the same SSL port, which I think you kind of touched on with using a remote connection.
Yes, so that's a good point, and I wanted to go over that one in a little more detail in particular. So when you create the certificates, the object servers can only bind to one certificate, and they'll bind to whatever certificate matches the certificate label within the key store matches the object server name. They can't bind to more than one certificate. So once they're bound to the certificates that have the common name AGGV, some clients like EventList, NCOSQL, and NCOPing will no longer be able to directly connect to the individual object server names AGGP and AGGB. They'll only be able to connect to the AGGV, the virtual common name that matches that certificate name. So I did want to show this in my example configuration. So I get questions a lot of time on how can I then connect to AGGB. For most of your end users, they won't ever need to really connect to AGGB directly. They can always use the virtual, and they'll only need to go to the backup if the primary is down for some reason. For your OMNIbus administrator, if you have a system with a primary and backup object server and the gateway alone, and it's not running any other probes or anything that would need to connect to the virtual object server, on your backup what you can do is you can run your AGGV, and you can see that my definitions for AGGB and AGGV are the same here. And this allows me to run the event list or NCOSQL on my backup object server, and it will connect directly to my backup object server by using the server name AGGV because it has to match. If you have a system that's running more things than just a primary and backup, and just a backup object server and gateway, if it's running probes as well and you can't do this, you could also look at having a remote install of OMNIbus just to use your event list and your NCOSQL utilities on your own system. And OMNIbus can connect from your own system to the object server. The administrator doesn't have this problem. And here I have a configuration of the administrator or NCO config. When you put in a definition and connect to it, you can still use AGGV, and it will say AGGV primary and AGGV backup, and you can connect directly to either one of those. There was one more comment in the question chat that FIPS 140-2 is typically a government requirement to be included in their config. And yes, FIPS 140-2 and the SP 800-131 are enhanced encryption standards. I did want to mention them because even if you're not a government entity, a lot of companies are having a requirement now to go to TLS 1.2. And so you would need to look at both of them to go to TLS 1.2 for the object server as well. Just because you have to enable FIPS 140-2 and then the SP 800-131 to enable the TLS 1.2 only. And that's within this SP 800-131 configuration file. You can see that there's an option in there, TLS 1.2 only set to true. And that won't allow any other connections other than TLS 1.2 to the object server. Are there any other questions?
Okay, it looks like there's one more. When is the SSL for Web GUI?
That one will be in about a month. It's not yet scheduled. The one for Impact SSL is, I believe, scheduled for April 14th. And we'll be having one for Web GUI in about a month from now. Are there any other questions? Okay, well, if there's no other questions, I wanted to thank everyone for joining. My contact information is in the presentation as well, so if you have any questions, you can always email me directly as well. And also, Kelsey has a discussion forum set up to post any questions.
Thanks, Christina. And thanks, everyone, for joining today's webcast. Feel free to continue any discussions in the Optimizing IT and Service Management Forum on the IBM Middleware User Community website. The link is located in your chat box right now. And also, again, the recording and slides will be available tomorrow in the IMWalk webcast archives. You'll receive a follow-up email with a link to those. As you exit, please take a few moments to fill out the post-event survey. This helps us improve future events. Thank you for attending today's webcast, and have a great day.